growth. And it's weird because the equations look funny, right? Like the minute you opened up the book, you're like, oh my gosh, right? So, and it's not terrible. There's just a lot, there's just a lot of explaining. So when you get logistic growth, it's of a certain form, okay? So the way that you can tell a logistic growth equation from any other equation is that there's multiple y's in the equation if it's a differential equation, okay? Or it looks like this equation down here. Okay, but the logistic growth comes from this particular type of graph. So, logistic growth graphs always kind of look like this. There's some threshold, there's some sort of line where there's what we call a limiting value. Or it's like a ceiling. Or they call it a cap. Or they call it the carrying capacity. It's like 5 different ways to describe the same thing. Okay, and it's labeled L, capital L. And when you do this, right, the reason why there's like a ceiling, right, like you think like this room has a ceiling in it, so I can't technically go above it and still be in this room. The reason why there's a ceiling is because it models population growth. We can't have an infinite number of animals, right? You can't have an infinite amount of people, otherwise they don't all fit on the earth. And so there's some sort of, so we always use like population growth as a logistic model because there's some sort of, like, it has to be finite. There's some sort of spot where I'm like, I can't go above that particular amount. Or like, you're going to put all these animals in the zoo. I can't have more than X number of animals in the zoo because that's the maximum amount I can have, right? It's just like winter formal, great example, other than the fact that we're all going to end up sick. But there's a limiting value, right, in that room. Because the fire marshal says you can't have more than X number of people in the room because it's not safe, right? So there's a limiting value. There's some sort of stopping point. I can be below that. I can be almost equal to it, but I can't be over it, okay? And that's where logistic growth comes into play. When you have these graphs, this line, right, represents the growth rate. And if I should do it a different color. Here's this little midpoint of that like sloping region. That's actually my point of inflection. Below this point of inflection is where the growth rate is increasing. or what we say is speeding up. And then on the other side, right, we say the growth rate is decreasing or slowing down. And it's slowing down because it's getting closer, right, to this asymptote of where I can't be over it. This point of inflection has a coordinate point. Its coordinate point is some sort of time, comma, my limiting value divided by 2. So it takes the limiting value and whatever that limiting value is and divided by 2, that's where your point of inflection is. Always divided by 2. This is the maximum, where the maximum growth rate occurs. Is this, and the maximum growth rate is this L over 2. The only reason why I teach you guys this section is because there is one multiple choice question on the AP test about what is the limiting value carrying capacity of the function. And that's it. That is the only reason why I teach you this section, is because I need you to be able to take this and figure out what the carrying capacity is, or I might need you to figure out what the max growth rate is, which means that you need the carrying capacity in order to find it. But there is one question on the AP test that asks this. That's it. Okay, so, but again, this is a race, right, to 54 points. So if I can guarantee you getting this multiple choice question correct, right, that's 1.2 points that I can guarantee. So again, I'm just trying to get us to that point. You'll see, you'll know that it's a logistic growth equation if your derivative is of this form. So you see 2 y's. And the y's are still the same. They're still a dependent variable. I mean, that hasn't changed. And L stands for the limiting value. Or the carrying capacity. These 2 equations are the same equation. The only difference between the first equation and the second equation is this second equation, I factored out 1 over L, right, from the first equation. That's it. That's the only reason why he looks different. Otherwise, he's the same equation. Now, you have to be able to figure out, when I give you a differential equation or a real life situation, what the carrying capacity is and what the max growth rate is. That's all you need to be able to figure out. Okay, so, and that's what your problem set looks like. We will still have beginning and end questions, right? Your end question today, though, I want you to do in the book. I'm going to try to save some paper by not having to duplicate your end questions. So I will give you an end question for today. And then your beginning question tomorrow will be also from that problem set. Okay. So if I look at this and I'm like, oh, what's the carrying capacity or the limiting value? And what's the y value at the point of inflection, right? You have to recognize that this is first a logistic growth equation, right? So because it's logistic growth, what form does it look like? It looks like the 1 minus y over L form. So what's my limiting value? My limiting value is 3, and my point of inflection y value is 3 over 2. That's it. Literally one of the easiest things in the world, right? But the hardest part is going to be I might have to do some algebra so that I can figure out what my carrying capacity is, right? Or what my max growth rate is. When I look at my second one, it looks like, oops, I cannot spell. It looks like L minus Y form, right? If I look at my two equations, it looks like the L minus Y. So what's my limiting value? Limiting Y value is 16, so the point of inflection Y value is half of that, which is 8. Questions that you guys have? Yes, Diego. Always half. Always half of the limiting value or the carrying capacity. I have not seen them ask it as the limiting value. I've seen it like example 3 and 4 of asking for the carrying capacity. So all the released questions that I've seen have been phrased as carrying capacity. So again, looks like 1 minus y over L. So my carrying capacity, if I read the directions, is 100, and my max rate of change is half of it, which is 50. Which all this so far looks all, bless you, all fine and dandy, right? Until I get to real world situations, which I want you guys to look at with the problem set. So what I did with the problem set too is I picked questions that I thought looked very similar to what you would actually see on your AP test. So there's like a couple multiple choice questions in there. As again, this doesn't show up on free response. It is always on multiple choice, and it's typically on the non-calculator multiple choice. At least that's where I've seen it. Okay, so this looks like L minus Y. So my carrying capacity is 7, and my max rate of change is 7 over 2. That's pretty much it. Okay. Questions that you guys have?